Alright everybody, what is going on? This video we're going to look at triple integrals in spherical coordinates. So let's go ahead and get started. Alright, so spherical coordinates, they're in the form of rho, theta, phi. And rho is positive, it's greater than or equal to 0. And phi is between 0 and pi. So let's just kind of draw a picture of what we've got here, and we'll label it and write some equations down and stuff like that. So, suppose you have a point. You have a point right here, and this is the point X, Y, Z in rectangular coordinates. Or we could write this point in spherical coordinates as rho, theta, phi. Okay? And so we have a line here, and this is rho, the distance from the origin here to this point, that's rho. And this angle here is angle phi. And let's see, let's draw a line right here. This is a right angle, and the distance from the origin up to here, that's Z. And if we project this point down here, let's see, I guess we can put the point maybe, let me bring this up a little bit, trying to make it a good picture, like this, and then go here, and we'll go here. So this would be X, this would be Y, and we have a line here to this point. We can call this P prime X, Y, 0. Z would be, the coordinate for Z would be 0 here. This is the point on the XY plane. We have another line right here. This distance here, that's Z. And then let's see, we've got an angle here is theta. And then this distance from the origin to the point in the XY plane, that would be R. All right. So let's see if we can get a couple of formulas here. And by the way, this angle here, that's a right angle also. I know it may not look like it, but it is. Okay. All right. So we have a point in rectangular coordinates X, Y, Z, and we need to get them in spherical coordinates. So we're going to need to know how to convert it. We know how to convert from rectangular coordinates to cylindrical coordinates, but how do we convert it to spherical coordinates? Well, let's look at this. All right, so we've got the angle phi right here. So do you see this line right here is the hypotenuse of this triangle right here? All right, and this side is adjacent. That's the side adjacent to phi. So we have cosine phi is equal to Z over rho. All right, and what about sine phi? Well, look, this line and this line here are parallel. They're cut by a transverse, so these angles here are equal. So this angle would be phi also. All right, and so you see this triangle here. Okay, this is the right angle. This is your hypotenuse. This is the side opposite phi. So remember, sine phi would be opposite over hypotenuse. So we've got sine phi is equal to opposite over hypotenuse. All right. And so this gives us that z is equal to rho times cosine phi, and we get r is equal to rho times sine phi. All right, I just solved this for z and solved this for r. All right, now let's look at this. We've got theta and r here. Well, you remember from earlier that x is equal to r cosine theta, and y is equal to r sine theta. All right. So what does that give us? Well, that tells us that x is equal to r times cosine theta. Well, what's r? Remember, everything needs to be in terms of rho, phi, and theta. So r is equal to rho times sine phi. So I'm going to replace this r with rho times sine phi, and then times this cosine theta. All right. And then what about y? Well, y is equal to r times sine theta. Well, r is rho times sine phi, so that's rho times sine phi times sine theta. All right. And then, of course, we already know what z is. Z is equal to rho times cosine theta. Rho times cosine theta. I'm sorry, not theta. Rho times cosine phi. All right. And then by the distance formula, we know that rho squared is equal to x squared plus y squared plus z squared. Okay, that distance from here to here. And so this right here, that's what you need to know. This is gonna show you how to convert from rectangular to spherical. All right, so that's just a little quick thing on how we get to that. All right, so let's look at our first example. It says we have the point 2 pi over 4 pi over 3 is given in spherical coordinates. Plot the point and find the rectangular coordinates. All right, so let's plot the point first. All right, so we've got our x-axis, our y-axis, our z-axis. So there's x, y, z. All right, so rho, that's 2. That's going to be the radius. That's how long it is, the line. Pi over 4 is theta. That's the angle off the x-axis. Pi over 3, that's phi. That's the angle off the z-axis. And so if we let's draw this right here. Let's see. This is our pi over 4. This angle here is pi over 3. This distance here is 2. There's your point. And so there's our point right here. This is the point 2 pi over 4 pi over 3. All right. So, they're not hard. It's not difficult to graph these things, but there it is. All right. So now let's convert the point that's in spherical coordinates to rectangular coordinates. All right, so let's go ahead and convert this. So let's write the point down again. So we've got the point 2, what was it, pi over 4, pi over 4, pi over 3. And remember, this is rho theta phi. All right, so remember, we've got to get this x, y, z. Okay. All right. So what is x? Well, x, now there I go hitting stuff with my hand again. All right, so x is equal to rho times sine phi times cosine theta. That's from, we found that earlier, the first thing we did. And so, well, that's what? 2 times sine phi, which is pi over 3, times cosine theta. Cosine theta, theta is pi over 4. And so that's going to be 2 times, well, the sine of pi over 3, that's square root of 3 over 2 times cosine pi, square root of 2 over 2. And so that's going to give us square root of 6 over 2. And then y is equal to rho times sine phi times sine theta. So that's 2 times sine pi over 3 times sine pi over 4. And that's 2 times square root of 3 over 2 times square root of 2 over 2, which is equal to square root of 6 over 2. And then what about z? Well, remember, z is rho times cosine phi. And so that's going to be 2 times cosine of pi over 3, which is 2 times, and cosine of pi over 3, that's 1/2. So that's 1. All right. And so we can see that our point, I'll just write it right here, that's square root of 6 over 2, square root of 6 over 2, 1. All right. So there you have it. So that's not too bad. Pretty easy. All right, so let's look at our next example. All right, it says the point 0, 2 square root of 3, negative 2 is given in rectangular coordinates. Find the spherical coordinates for this point. So we're going the other way with it now. All right, so let's, I guess first we can find rho. So remember, rho squared is equal to x squared plus y squared plus z squared. So that's going to give us rho is equal to 0 squared plus 2 square root of 3 squared plus negative 2 squared, and it's the square root of all that. And so this is going to be square root of 0 plus 12 plus 4, which that's the square root of 16, which is 4. So there's rho. All right. All right, now we've got to get what? So let's write the point. We need rho theta phi. Okay. All right, so we got rho. Now I guess we'll find phi, or we could find theta first. It doesn't matter. Let's find phi. So we've got z is equal to rho times cosine phi. Okay, that's one of the formulas we had earlier. So this means that cosine phi is equal to z over rho. All right, z over rho. So this tells us that cosine phi is equal to z, which is, so you remember this is x, y, z. That's negative 2 over rho. Well, what's rho? Rho is 4. So this means that cosine phi is negative 1/2. And remember, phi is between 0 and pi. All right, so is phi, is it a first quadrant or second quadrant angle? Well, it's second because cosine's positive in the first, negative in the second. So, you know, if you look at this, okay, here's your first quadrant, here's your second quadrant, and we know this is phi right here. So we need our reference angle. We'll call that phi prime to represent the reference angle. So remember, the cosine of your reference angle would be a positive 1/2. Okay, so the cosine of what is positive 1/2? That's 60 degrees, or pi over 3, right? And so we can see that phi, I'll do it right here, phi is equal to pi, see, pi minus pi over 3, which is 2 pi over 3. And so this tells us that phi is 2 pi over 3. All right, so now we need to do what? We need to find theta. Well, what do we know about theta? Well, I guess you say we got a couple of options for theta. We know that x is equal to I don't know. Let's use this one. Rho sine phi times cosine theta. So this tells us that cosine theta is equal to x over rho times sine phi, which this tells us that cosine theta is equal to x, and x is 0 in this case, over rho, which is 4, times sine phi, which is sine of 2 pi over 3, which means cosine theta is equal to 0, which that tells us theta is equal to pi over 2. Okay, and so there you have it. Your spherical coordinates are 4 pi over 2 and 2 pi over 3. All right, so there's the answer to that one. All right, so well, I'll talk about this picture here in just a minute, but let's look at this. So we've got the triple integral over region E of x, y, z times dv is equal to the triple integral c to d, alpha to beta, a to b of f of rho, and I'm not going to read all that, but just remember, this is your, see the x, y, z, there's your x, your y, and your z, okay, times rho squared sine phi d rho d theta d phi, where E is a spherical wedge given by E is the points rho, theta, phi, such that rho is between A and B, theta is between alpha and beta, and phi is between C and D. All right, so let's just talk a minute about this. Okay, this dv. Okay, so I went ahead and drew the picture because I'm horrible at drawing these things, but let's look at it. We can see dv, okay, this volume here, this little cube-like thing. All right, so if you go to get the volume, well, what's the volume of this thing? Well, hopefully you can see that it's going to be this, okay, this length here times this length times this length, and so that's going to be rho d phi times rho sine phi d theta times times d rho, which we'll rearrange everything. That's rho times rho. That's going to give me rho squared times sine phi, and then d rho d theta d phi. And there's your dv. That's where that comes from. All right. All right, so let's look let's look at an example here. So we have this example. We have the triple integral over region B, where we have e raised to the x squared plus y squared plus z squared, and that's raised to the 3/2 dv, where b is the unit ball, and b is equal to the set of x, y, z, such that x squared plus y squared plus z squared is less than or equal to 1. All right, so let's sketch a graph of this thing. Okay, let's graph this thing. All right, so we've got, there's your x, your y, and your z. Okay, so this is a sphere where we've got center at the origin. All right, and what we need to do is we need to set this thing up. Now, the first thing I want to do is I want to set this thing up in rectangular coordinates, just so you can see what we have here and show you what you would have to integrate. And then we're going to set it up in spherical coordinates to show you the difference. All right. So this is a sphere right here, and keep in mind this is the square root of 1 minus x squared minus y squared. See, we got our sphere right here. So that's the top half of the sphere, and then the bottom half would be negative square root of 1 minus x squared minus y squared. And then if we come over here and we look at the projection in the xy plane, it's a circle, right? It's a circle. And so if we draw that, there's your projection in the xy plane, xy. And we know this is x squared plus y squared. And this circle will be less than or equal to 1. See, at the center, that would be the circle x squared plus y squared equals 1. And then it's just going to get smaller as we move up or down the sphere. So this top half, the top half here, that would be the square root of 1 minus x squared, and the bottom half would be negative square root of 1 minus x squared. And we know this is negative 1 to 1. So let's look at this if we set this up using rectangular coordinates. So I've got the triple integral. All right, so we'll integrate with respect to z, y, and then x. All right, so if we integrate with respect to x, that's going to be from 0 to 1. 0 to 1. And then if we integrate with respect to y, well, that's going from here to here, right? So that's going to be negative square root of 1 minus x squared to square root of 1 minus x squared. And then this last one here, well, we're integrating the sphere, which is going from here to here. You see that? And so that's from this bottom half, which is negative square root of 1 minus x squared minus y squared, up to the square root of 1 minus x squared minus y squared. And then that would be e raised to the x squared plus y squared plus z squared raised to the 3/2. And that would be dz, dy, dx. And so if we were doing this in rectangular coordinates, that's what you would be integrating. And that doesn't look fun at all, does it? Okay, so there it is set up in rectangular coordinates. Now I'm going to erase all this and we're going to set it up in spherical coordinates. It's going to make it a lot easier. All right, so I got everything erased. So now let's set this up in spherical coordinates. So we got up here B is the set of all x, y, z such that x squared plus y squared plus z squared is less than or equal to 1. All right, so let's set it up. So we've got B is equal to the set of rho, theta, phi such that. All right, so I need to know what is rho between, what is phi between, and what is theta between. Okay, and it's pretty easy. Well, I know the distance from here out to wherever on the sphere, that's going to be from 0 to 1, right? So that's 0 less than or equal to rho less than or equal to 1. All right. Now let's talk about phi. All right. So phi, let's extend this down. So what's happening here is phi. You can see what we do is we rotate it. Remember, phi is rotated off the positive, off the z-axis. And what we're doing is we're rotating this sphere here. We're rotating it, and we have the sphere here. And it just goes from 0 to pi, and then we rotate it around the z-axis with theta. And theta is what? Theta is going all the way around, isn't it? It's making a sphere. Okay, so like if you had, and you'll see in another example, in the next example, we can rotate it down to here and then rotate it around. Okay, but that's what's happening. We're not going to rotate phi all the way around and then have to rotate it, and it's hard to draw, but rotate it, rotate it around the z-axis once we've rotated it all the way around. So phi is just going from 0 to pi. And you can see that's the case right here. And so we've got 0 less than or equal to phi less than or equal to pi. And then of course theta, that's rotating around the x-axis, about the x, rotating measured off the x-axis, and you can see it's going all the way around. So we've got 0 less than or equal to theta less than or equal to 2 pi. All right. And so now we have the triple integral b of e to the x squared plus y squared plus z squared raised to the 3/2 dv is equal to, and we're going to go 0 to pi. We'll integrate with respect to, let's see, where is it? We'll integrate with respect to rho, then theta, then phi. All right. So rho is, rho, theta, then phi. So this would be phi, this outside integral. So that's 0 to pi. And then theta, that's 0 to 2 pi. So 0 to 2 pi. And then rho is 0 to 1. All right. And then that's going to be e raised to what? Well, what is x squared plus y squared plus z squared? Well, we know that rho squared is equal to x squared plus y squared plus z squared, right? And so that's e to the rho squared, and then, and that is raised to the 3/2. And then that's times rho squared sine phi d rho d theta d phi. All right, so let me just rewrite this one more time. 0 to pi, 0 to 2 pi, 0 to 1, and all I'm doing is writing this as e to the rho cubed. Okay, multiplied those two. That's all I did. Rho squared sine phi d rho d theta d phi. All right. And so what are we going to do now to integrate this? Well, look at this. we can split it up into three integrals. So that's going to be 0 to pi, and that's what? That's d phi, right? See, that's d phi, this first integral here. So that's going to be sine phi d phi times the integral 0 to 2 pi, and that's just going to be d theta, and then times the integral 0 to 1 of e to the rho cubed. Well, let's do this. We've got rho squared e to the rho cubed d rho. All right, so this is going to give us what? Negative sine phi from 0, I'm sorry, not negative sine, negative cosine phi from 0 to pi. Okay, that's the first integral. And then that's going to be times theta from 0 to 2 pi. So those were easy to integrate there. Now, the last one, I'm going to have to use u substitution, right? Have to use u substitution there. So that's going to be, let's see, I'm going to let u equal rho cubed. So du is 3 rho squared d rho. All right, so look at this. I've got rho squared dp. I'm missing the 3, so I'll multiply by 3, come out here and multiply by a third. And so that's going to be times 1/3. And then I make my substitutions. So e to the u, let's do this. I didn't need the bracket there. So that's going to be e to the u. So the rho cubed I'm replacing with u. And then the 3 rho squared, see, 3 rho squared dp, I'm replacing that with du. And then I have to change my limits. And so u is equal to rho cubed. So I've got to take this 0 and plug it in for rho. So that's 0 cubed, which is 0. And u equals, then I plug the 1 in, 1 cubed equals 1. So the limits didn't change. I mean, they did, but they turned out to be the same numbers. That's not going to always be the case. And so this is going to be negative, I don't know, let's do negative cosine pi minus cosine 0 times 2 pi minus 0, I'm just evaluating these, times 1/3 e to the u from 0 to 1. And so, let's see, that is, that's negative 1 minus 1 is negative 2 times negative 1 is positive 2. That's 2 pi. So times 2 pi, and then times 1/3. Let's do it like this. Times 1/3 times e to the 1 minus e to the 0. And so that just ends up being 4 pi over 3 times e minus 1. And there's your answer. All right. All right, so let's look at another example, and this is the last one. Okay. All right, so we've got used spherical coordinates to find the volume of the solid that lies above the cone, z equals square root of x squared plus y squared, and below the sphere, x squared plus y squared plus z squared equals z. All right, so let's draw a picture. So we've got x-axis, y-axis, z-axis, x, y, and z. All right, so the cone here, we know that's just the top half of the cone, okay? So we've got our cone right here. Okay. And then, so it lies above the cone, and below this sphere right here. So what is that? What is that sphere? Well, we've got what? X squared plus y squared plus z squared minus z, minus bringing the z over, leave a little space here, equals 0. So that's x squared plus y squared. Now this, we'll complete the square on this. We take the negative 1 and half it. That's negative 1/2. Square it. That's going to give us plus 1/4. So plus 1/4. And so that's going to be plus z minus 1/2 squared equals 1/4. So we know we've got a cone. We've got, I'm sorry, not a cone, but we've got a sphere. And I don't know if I called this a cone earlier, but if I did, I meant a sphere. So this is a sphere with center 0, 0, 1/2, and the radius is the square root of that, which is 1/2. And so we've got a, let's see if I can draw this halfway decent. It's going to be a sphere that goes around like this. The center is going to be at 1/2. Okay, but it's where this cone and the sphere intersect. So it's below the sphere, but above the cone. So we're just going to have the top half of the sphere. Okay, this would have the equation x squared plus y squared plus z squared equals z. Okay, and this right here would be your point 0, 0, 1 at the top right here. So we're just using the top half. All right, so we need to get all of this in spherical coordinates. All right, so let's see what we can do here. Well, we know that x squared plus y squared plus z squared is equal to z. So this is telling me that rho squared is equal to z. Well, what is z? Well, do you remember earlier when I showed you how to find the x, y, and the z to go from rectangular coordinates to spherical coordinates, that z is rho times cosine phi. And so this tells me rho is equal to cosine phi. Divide everything by phi. Okay, so this is actually right here. This is the equation of the sphere in spherical coordinates. Okay, and then I know that the equation of the cone is z is equal to the square root of x squared plus y squared. Now I'm taking the equation of the sphere and I'm taking the equation of the cone and I'm putting them in spherical coordinates. And so, well, what is z? Well, remember z, that's rho times cosine phi, is equal to the square root of x squared. Well, what was x? Remember x? Well, that's rho times sine phi times cosine theta, and that is squared. Plus, so that's the x and squared, and then plus y. Well, what was y? That's rho times sine phi times sine theta, and all of that squared, and then I need the square root of that. And so this is going to be rho cosine phi is equal to rho squared sine squared phi cosine squared theta plus rho squared sine squared phi sine squared theta, and it's the square root of all that. And so I get rho cosine phi. See, I can factor out a rho squared. Well, look at this. I'm factoring out a rho squared sine squared phi, And when I factor that out, what's the square root of rho squared sine squared phi? That's just rho sine squared phi times the square root of cosine squared theta plus sine squared theta, which that we know is 1. So I get rho cosine phi is equal to, whoop, that's not a sine squared, that's just sine. Rho sine phi. So this tells me that cosine phi is equal to sine phi. And where are they equal? Remember, phi is between 0 and pi. Well, cosine and sine are not equal in the second quadrant. They're equal in the first quadrant. So this tells me phi is equal to pi over 4. Okay. All right. So let's see if we can't set this up. So I know this angle here is pi over 4. That's phi. All right. So if I set this up, I wish I could write it out. Let's bring it down. Let's write E right here. So E is equal to the set rho theta phi such that, all right, so this is where we've got to set up our bounds on our integral. All right, so the first one I'm going to set up is theta, because we'll do it d rho d phi d theta. So theta, that's the angle going this way. So you can see we're going all the way around. So that's going from 0 to 2 pi. And then I'm going to set up phi. So phi, that's going from what? 0 to pi over 4. 0 less than or equal to phi less than or equal to pi over 4. And then rho, well, notice rho, that's going from here to, maybe some point on the sphere. You can kind of, I don't know, maybe look at it like this. See, it's going somewhere on that sphere. It's going from the origin here to a point on the sphere. And what is this point going from 0 to this sphere? Well, remember we need the sphere in spherical coordinates, and that is this. So rho is between 0 and cosine phi. Okay. All right, so let me grab this and just kind of pull it down here so we'll have it. Come on. All right, so there we go. So we've got the volume of E, which is the triple integral over the region E dV. So remember, when we're finding the volume, it's 1 times dV. Okay, so that's going to be 0 to 2 pi, and then 0 to pi over 4, and then 0 to cosine phi, and that's 1 times rho squared sine phi d rho d phi d theta. All right, so there it is set up. Now all we have to do is just integrate this thing. So can we split it up? Well, we can't split it up into 3 like we did earlier. We can split it up 0 to 2 pi and that's going to be d theta, and then that's going to be times 0 to pi over 4, 0 to cosine phi. So we got the cosine phi there, so we can't split that up. And that's going to be rho squared sine phi d rho d phi. All right, so now let's integrate this. So we got 0, I'm sorry, not 0. We've got theta going from 0 to 2 pi, and then we've got 0 to pi over 4, and then we integrate this. And so remember, our variable is rho. Sine phi is like a constant, so the integral of rho squared, that's going to be 1/3 rho cubed times sine phi, and that is going to be from rho equals 0 to rho equals cosine phi, and then d phi. All right, so let's see what we've got. Well, this thing over here, this is just 2 pi. So that's 2 pi, and that's going to be 0 to pi over 4. And let's see, that's going to be 1/3 sine phi, and then that's going to be times cosine cubed phi minus 0 cubed. I plug in the cosine phi and then plug in the 0, and that's d phi. And so that's 2, now let's do this. That's 2 pi over 3. I'm going to pull out the 1/3, 0 to pi over 4. And that is basically, that's going to be sine phi cosine cubed phi d phi. And so what do we have here? Well, that's u substitution. So I'm going to let u equal cosine phi. So du is equal to negative sine phi d phi. And so you can see here, I need negative sine phi d phi. I don't have a negative, so negative. If you, whatever you do on the inside, you got to do the opposite on the outside. So if I multiply by -1, I got to multiply by the reciprocal of -1, which is just -1. And so this is going to be negative 2 pi over 3 times the integral, and that's just going to be u cubed du when we make the substitution. But then we have u is equal to cosine of 0. I got to plug the 0 in for phi and the pi over 4 in for phi. So that's just going to be 1. And then u equals cosine of pi over 4. That's going to be square root of 2 over 2. So this is 1 to square root of 2 over 2. Now, the larger bound is on bottom here, and the smaller one's on top. We can actually switch those, and that'll change this to a positive. So that's 2 pi over 3 from square root of 2 over 2 to 1 of u cubed du. And so we get what? We get 2 pi over 3 times 1/4 u to the 4th from square root of 2 over 2 to 1. And once you do all that, I'm not going to show all the work, but you get pi over 8. And that's your answer. Okay, so you see, it's not really that difficult to solve these things or set them up. So, you know, just take your time, try to sketch you a good picture. I know I'm not the best at drawing these things, but hopefully you're better than I am at drawing them. So, but yeah, that's the triple integrals in spherical coordinates. So I hope this video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching. See y'all in the next one. Later.